So what you're seeing here is a hotel and suite called Carib Royal. This is where we had the ITA conference in Orlando, March 25th to 29th, 2004. This is just a demo, but the idea can be used maybe to develop or to cause it to do a lot more other tasks in technical field. Is that what you're saying?
Yeah, so they could do a range of activities from creating a dance routine like Thriller you just saw to actually programming him to do a task. So going to find a red ball, to pick up the red ball and bring it back.
Okay.
Or to interface with other robots or interface with other students. Just it's the access to all of those sensors give it the abilities.
All right. All right. So this is what our group produced as part of the challenge we were given to produce a cooler using just 3 materials, right? Yeah. Gently. Okay. Wow, I can see Ice Cube. Team members. Luis and
Lana
and myself. Okay. All right. There's a dirty car. We want to clean it.
Okay.
All right.
So here is
6 holes now. Let me see. Okay. So put the water.
here. Aim it, and I'll drop the water. Aim the holes directly over it.
Right there. Oh.
We need a little. Yeah, at the front. This is more wasteful with 6 holes. I can see it already. And the front hood. There's a little bit in the front hood. There you go.
But the thing is, we'll find it difficult to measure the volume of water that has been used. I thought we were going to put everything at once so that we see.
Here's where we started.
Okay.
Here's
Okay. You've noted it, huh?
Yeah.
All
so
right.
this is the second line. Right here. And then right now we're way down here.
Down
we
there.
wasted a lot of water to get this one clean.
Yeah.
So 6 is worse than 3. It's more wasteful, of course, which makes sense. Alright, so now we try the bag, right?
The back, right? Okay.
So let's go.
For the back, we're cutting the corner. Okay.
It looks kind of big. But...
And then we pour the water. We still have our dirty car here.
Alright.
Watch
So,
it. Be careful.
What do you say we pour it in first?
First.
Oh,
and then tip it over.
And then tip it over.
That's a good idea.
Okay. Ooh.
a single stream.
Yeah.
That's a stream already.
So, this is where we started.
2 or 3 minutes.
So
That-
dump
yeah.
this back
So
in.
return it.
Temporarily finish with this, and then we're going to move on.
Wow.
The fourth grade.
A lot less
Okay.
water. It didn't go down very much.
But it was fast.
Yeah.
Even faster.
A lot faster. We're down here. So we went from here.
Okay. Okay. I know the circuit diagram might not be easy for us to draw, but we should be able to sketch it.
How are we doing with
This.
Yeah.
Alright, so that. So now we're going on this one.
Yeah. This is how it looks. The two of them. The original product and the circuit diagram we've just drawn. Okay.
They're called test leads, also from Pittsco. Okay, engineers do things like this where they do temporary circuits to just find out how they're going to work, okay, if they're going to work. Okay, so in order to, this is an LED. Okay, this is the type of LED that a lot of us see in home appliances and things like that, where you see a little green or red light glowing. Okay. So these you would buy, say, at Radio Shack would be a good local source. They're actually very expensive when you buy them at Radio Shack. Okay, but okay, you can get them really cheap. The way you get them really cheap is you buy Christmas lights.
Okay.
And you cut these up into little pieces. Now, the one thing about LEDs is you need to know polarity. You need to know the positive side and the negative side. So I have two different colors of electrical tape. And I challenge teachers and students to determine which is going to be your positive side, which is going to be the negative side. And so we would put, after we cut these up, we would figure out how to light them up, and we would put a little bit of red tape on one side, a little bit of black tape on the other. Because everything in electricity that we're doing has this red and the black, and the red side is going to be positive, and the black is going to be negative. Okay.
And Radio Shack doesn't carry black and red anymore.
We said engineers really do. Okay. This is only lesson 2. Okay, it's designed to do some math. In lesson 3, they learn about the grand challenge. Okay, and they learn about their student challenge. The student challenge, again, is going to be to build this model fort, treehouse, and so on. On the top of their treehouse, they are going to need probably somewhere between 2 and 4 of these in order to get this light to work. Okay.
That's what I expected.
Okay.
So we have the tires.
Actually, we're off a little.
Yeah. The pin, the axle.
The axle sticking out. Let me redo this.
Need to be parallel.
Let's see.
We would like you to be ready to race about 20 minutes from now. I think that's practical. Kind of friendly race.
Great.
Once again, let's stick out. We'll go right here.
Okay.
Here.
And there it goes. One. 1, 2. Yeah.
Chug it.
Going.
That's a train.
You let me know, Liz, when you're ready. Okay, I've started. Oh, that's the best one yet, Liz.
Good.
That's
You're
good,
gonna need a
that's
longer
good,
table
that's
now.
good.
Oh,
yeah,
buddy.
We can just take one sticking out this direction too. Forward probe.
But is it supposed to be just vertical or at an inclined angle? To give it a kind of balance. From the sketch, the ideas we had already, I mean initially, it's like the props are really not going to be vertical, straight down. Straight down, man. Oh, they are going to be straight down?
Well, I mean, for this,
I thought they would be at an angle, inclined at an angle.
Are you taking a video or?
Yeah.
Okay.
This is the group trying to build a rover that can be transported to Titan.
Now we got arms going every direction. We'll stand up.
There you go. Yeah. So we're trying to make the legs, huh?
Yep.
Okay.
Isn't that great? We both clicked over the reds and got here. We decided we wanted to go to Jupiter because there's two becauses. One, because it's the fifth, almost in the middle, so it's middle ground to get us a little more knowledge maybe of where we've been already and where we're going to. And the other reason is because it's the biggest. It's the biggest, and so we think there might be a lot to explore. So this is our creation that will allow us, because Jupiter is known as the gases one. We're not sure if there's terrain. So we're planning for it, that maybe if we delve deep into the gases, we might get there. You might learn a little bit more. So we want to test for temperatures, we want to test the gases, and if there is terrain, we might get to that point. But this is our little gas collector. It's our little ball we're going to throw out to collect gases, right here. We want to get the temperature, so we're going to fling out our little temperature thing that's going to tell temperatures. We've got the little cushy spots so that it, upon landing or maneuverability, we've got protection, and we've
got propellers to help us move around in all this gas, and we even got springy type things that we can kind of maybe get a little bit of
resistance and so that is our prototype.
Why? This was staying together pretty well until. Okay, let's pretend like that's staying together. So it should be a little more level. It's amphibious, it flies, and it has the pivoting points that the rover has, so that it'll be able to go over rough terrain. And then the wings would have solar panels on it, and this can come down level. So
where are you going?
Titan.
Titan. Why do you want to go to Titan?
Because he wouldn't let me go to Uranus.
Thank God.
But what we're looking to do is to analyze some material from this heavenly body. So I'll let Lindsay kind of tell you a little bit about Pandora, and I'll come back and we'll talk about what our thing is supposed to do.
Okay, so we just picked a moon. We looked at the moons of Saturn and just randomly picked Pandora. It's relatively small. I think one of the things we read was that it's 52 miles long or 52 miles wide. So it has very little gravity. I think, what did we write down? 6,000. So there's really hardly anything keeping stuff there. Very ice, very cold, extremely cold, freezing. So a lot of what the moon has is ice. There's a lot of crater, and there's also a lot of debris. So we wanted to design something to not only stay on the moon, we also want to design something to move in and out of the craters and through the debris as well.
Terrain. So our little vehicle is going to, we want it to be able to move slightly. We want to retrieve some mineral samples by drilling through a thin layer of ice and grabbing or somehow we didn't get to that part yet.
Yeah, sure.
We wanted to get this out. So as this thing was maneuvering, we wanted it to always fall so that it
Regardless
would
of how it landed, we wanted it to be able to still be able to move. There's
So we
no
have-
up or down.
so we have a lot of little tracks mounted there. We didn't have enough time to make all the directions, but what we wanted to do was to get it in a position to make a drill straight down. Of course, the problem is that as soon as you start to put pressure down, you have a pressure up. So we need some kind of thruster to always be keeping our vehicle down on the ground. And inside there is a really complex analyzing laboratory and transmitting unit that will send this back, because this is going to Pandora and stay.
Yeah, of course.
Pandora.
Great, great.
Yeah.
For you, so I'm expecting great things.
So I'm University of Idaho, originally from Ohio. Simon, you're from
Jamaica.
Please pronounce that.
Tyler.
Gotcha.
Tyler.
Jeff from Missouri.
And
It's an international team.
She's adamantly not answering that.
Okay, got it.
Titan's always been a favorite of science fiction fans because of its believability. We liked it because it provided some differences from Mars. The thick atmosphere gave us an opportunity, so we went with a blimp type design.
Cool.
Semi-rigid,
Absolutely.
since you have the cold temperatures and the problems with the, if you were flexible, you'd have the freezing problems and you'd lose your flexibility. The idea of the mission is to explore 5 pre-selected sites over the entire planet for possible next mission and setting up eventual habitation. So what we have is semi-rigid with the gondola, cameras, 360-degree vision around it, probably the fisheye lens, so you can see a little bit of everything correct for it. The thrusters on the side, we're going to fuel it with methane. There's supposed to be liquid methane on the surface, and if there's not, you still have the solid methane on the surface. So you'd have to suck that up. There's also water available on the planetary surface. It's kind of rock-like. That could provide the hydrogen if we use electrolysis to fill the bag. Since the atmosphere is nitrogen, it should float. Various sensors. Another thing we added was, I guess we didn't get them on quite in time, some missile ports up front. Kind of looks like the desert out in Utah, or places, a lot of places do on Titan. And one of the problems with the missions like to Mars and such is you don't get a chance to ensure you're going to see new strata. So if you were able to actually shoot a projectile at the mountainside or the cliffside or whatever, you'd be able to expose the strata to do your analysis, spectrum analysis on it and see what's there. So that's kind of the theory, and just fly it around the world.
Very cool.
And see what's happening.